Hello, welcome back to Equation. Today you're going to learn how to solve every question from the APCSA 2019 FRQ. Question 1, we're looking at the AP calendar class. It has a private static Boolean method is leap year that returns true if year is leap year and false otherwise. It has a public static int number of leap years method that returns the number of leap years between year 1 and year 2 inclusive. It has a private static int first day year method that returns the value representing the day of the week for the first day of the year, where 0 denotes Sunday, 1 denotes Monday, and so on down to 6 denoting Saturday. It has a private static int method day of year that returns n, where month, day, and year specify the nth day of the year, or returns 1 for January 1st. And finally, it has a public static int day of week method that returns the value representing the day of the week for the given date, where 0 denotes Sunday, 1 denotes Monday, and 6 denotes Sunday. For question 1a, we're writing the static method number of leap years, which returns the number of leap years between year 1 and year 2 inclusive. In order to calculate this value, a helper method is provided for you. Is leap year returns true if a year is a leap year and false otherwise. For the code for 1a, you're writing public static int number of leap years, initialize an initial num leap years variable to 0, you loop through the range of the years, so for int I equal year 1, I less than year 2, I plus plus, increment num leap years defines a leap year, and then finally at the end, return num leap years. For question 1b, we're writing the static method day of week, which returns the integer value representing the day of the week for the given date, month, day, year, where 0 denotes Sunday, 1 denotes Monday, on down to 6 denoting Saturday. For example, 2019 began on Tuesday, and January 5th is the 5th day of 2019. As a result, January 5th, 2019 fell on a Saturday, and the method called day of week 1/5/2019 returns 6. As another example, January 10th is the 10th day of 2019. As a result, January 10th, 2019 fell on a Thursday, and the method called day of week 1/10/2019 returns 4. In order to calculate the value, two helper methods are provided for you. First day of year returns the integer value representing the day of the week for the first day of the year, where 0 denotes Sunday, on down to 6 denoting Saturday. Day of year, month, day, year returns n, where month, day, and year specify the nth day of the year. For the first day of the year, January 1, the value 1 is returned. This method accounts for whether a year is a leap year. For the code for 1b, you're writing the method public static int day of week. You're getting the first day of the year and you're getting the year day. First day plus year day minus 1 gives you the number of days that have passed since the first day. And then the mod 7, because that makes it so the pattern is cyclical and it loops back to 0 every 7 days. Finally, at the end, once you've gotten the explanation for why, first day plus year day minus 1 and that whole expression mod 7, you're going to return. For question 2, we're looking at the step tracker class. A step tracker object is created with a parameter that defines the minimum number of steps that must be taken for a day to be considered active. The step tracker class provides a constructor in the following methods: add daily steps, which accumulates information about steps, ingredients taken once per day, active days, which returns the number of active days, average steps, which returns the average number of steps per day, calculated by dividing the total number of steps taken by the number of days tracked. For the code for 2, you're writing the step tracker class. You have all these members: private int min active steps, the minimum number of steps to be active, private int total steps, private int days, private int active days. You'll see why you need all those as we go through the methods. You have a constructor, public step tracker int min. You set the min to the minimum active steps. Public void add daily steps, you take in steps, you increment total steps. If the steps greater than or equal to min active steps, you increment active days, and then no matter what, you increment days. Public double average steps. If there's no days, there's no average steps, so if days equals 0.0, return 0.0. In this last one, the cast to double is needed, otherwise integer division, so you're returning cast to double, total steps divided by days, and then finally you have an active days getter where you just return active days. For question 3, we're looking at the delimiters class. Make special note of these first two, private string open del and private string closed del. The class itself will tell you what the open and closed delimiters are. You don't have to solve it yourself or do anything clever. It has a constructor method. It has a public arrayless of string get delimiters list method. And it has a public boolean is balanced array list of string delimiters method, both of which you'll implement. For question 3a, a string containing text and possibly delimiters has been split into tokens and stored in a string array of tokens. Each token is either an open delimiter, a closed delimiter, or a substring that is not a delimiter. You will write the method getDelimiters_list, which returns an array list containing all the open and closed delimiters found in tokens in their original order. For the code for 3a, you're writing a public array list of strings getDelimiters_list method that takes in a string array of tokens. You're declaring a container that holds strings. You're looping over the whole tokens array. You're declaring a current string on every iteration of the loop. And I'll remind you, if you don't know this already, you have to compare strings with dot equals, otherwise you'll get unexpected results. So if current dot equals open del, or if current dot equals closed del, you add the current delimiter to the container, and then at the end of the loop, you return the container. For question 3b, you're writing the method isBalanced, which returns true when the delimiters are balanced and returns false otherwise. The delimiters are balanced when both of the following conditions are satisfied, otherwise they are not balanced. When traversing the array list from the first element to the last element, there is no point in which there are more closed delimiters than open delimiters at or before that point. The total number of open delimiters is equal to the total number of closed delimiters. For the code for 3b, you're writing the Boolean method isBalanced that takes in an array list of strings called delimiters. You declare an open and closed variable, both 0. You loop through the delimiters, so for int I equals 0, I less than delimiters.size, I++. You declare a current string. If current dot equals open delimiter, increment the opened variable. Otherwise, it will equal the closed delimiter, so increment the closed variable. The first case where the delimiters are balanced is if you have more closed delimiters than open delimiters, so return false. Outside the loop, the second case where the delimiters aren't balanced is if the number of closed doesn't equal the number of open, so return false. Otherwise, they have to be balanced, so return true. For question 4, we're looking at the lightboard class. It has a private 2D Boolean array of lights, as it has the constructor that you're going to implement, and it also has the evaluateLight method that you're going to implement. For question 4a, you're writing the constructor for the lightboard class, which initializes the light so that each light is set to on with a 40% probability. The notion, lights R sub C, represents the array element at row R in column C. Complete the lightboard constructor below. For question 4a, you're writing the lightboard constructor that takes in an integer num rows and an integer num columns. Initialize the light member, lights equals new boolean num rows num columns. Loop through the 2D array, for int I equals 0, I less than lights.length, I++, for int j equals 0, j less than lights sub 0.length, j++. Get a random number, so double num equals math.random, that declares a random number from 0.0 to 1.0. If num less than 0.4, so you give it a 40% chance of it happening, lights I sub j equals true. Otherwise, lights I sub j equals false. For question 4b, you write in the method evaluateLight, which computes and returns the status of a light at a given row and column based on the following rules. If the light is on, return false. If the number of lights in its column that are on is even, including the current light. If the light is off, return true if the number of lights in its current column that are on is divisible by 3. Otherwise, return the light's current status. For the code for 4b, you're writing a public Boolean evaluateLight method that takes in a row number and a column number. Initialize the status variable to the light's row column. Initialize an integer variable, numOn. You're looking at just a column, so you're only going over a row. For int I equals 0, I less than lights.length, I++. If lights I sub col, increment the numOn, because that would mean a light in that column is on. If it's on and even, return false. If status and numOn %2 equals 0, return false. If it's off and numOn divisible by 3, return true. If not status and numOn %3 equals 0, return true. Otherwise, just return the status. I normally make videos covering Python, Java, and JavaScript, so if that sounds interesting to you, please subscribe.